In UniFi Network Controller, for your Wi-Fi SSID, there is an interesting setting called Client Device Isolation. If you move your cursor on the icon, you can see the short description. So, of course, it explains what isolation means, but the problem is it says prevents the Wi-Fi clients on the same AP from communicating with each other. The same AP thing really doesn't make sense to me. For example, what if your Wi-Fi client moves to another AP in the same network? Does that mean all of a sudden your device can communicate with the other device because it's not on the original AP anymore, right? That's the trigger for me to make this video. Of course, in the video we will discuss much more details about this Wi-Fi feature from Ubiquiti. This is my lab environment. I use a UniFi Enterprise PoE switch to power two UniFi access points, Enterprise and Pro. I'm going to use two client computers in different scenarios. I also have a Linux virtual machine connected to the same environment. It will be used in one of the scenarios. To really understand what happens when these two computers communicate with each other, I'm going to capture the network frames, both the Wi-Fi frames and the regular Ethernet frames. We will look into the details during the testing. And I'm going to cover 5 different scenarios. The first scenario, very simple. So you don't have the client device isolation enabled. What really happens when these two computers communicate with each other? The second scenario, if they both have the client device isolation enabled, what will happen? The third scenario, if only one of them has the isolation setting enabled, whether they can communicate with each other. And the fourth scenario, what if these two computers are connected to two different access points, whether it will have any difference compared with just one access point. In the last scenario, I'm going to see when you have the client device isolation enabled, whether your computer can connect to device which is not on Wi-Fi. In UniFi Network Controller, I already set up two SSIDs, one to enable the client device isolation, the other one have it disabled. Let's check the enabled one. Everything's regular. I only set it to broadcast on 5 GHz and I enabled the client device isolation. That's it. So now we are ready to start the scenario 1 testing. For scenario 1, I want to connect the two computers to the same access point and the Wi-Fi setting is client device isolation disabled. As you can see in the lower part of the screen, for the two physical machines, I connect both of them to the ZCDI no SSID. I'm ready to validate whether they are able to communicate with each other. From the first computer, let me ping the IP address of the second computer. Of course, it's pingable. Right? Let me capture the frames. First, Ethernet frame. Choose the Wi-Fi interface. Start capturing. You may know because the monitor mode is not enabled. So in this way, I'm only going to capture the Ethernet frames. That's exactly what I want to capture. Then let me go back to the terminal. Only ping the second machine once, just one frame, so that we can have narrowed frames to analyze. Okay, done. Stop capturing. Let's check what's captured. The very last two frames. The first from the computer 1 to computer 2, and the protocol is ICMP for ping. And the second frame is the reply from the second computer back to the first computer. That's ICMP response. Why only 2 frames? Because I deliberately only use one packet during the ping, right? Everything makes sense. But this information we captured has nothing to do with Wi-Fi, and this testing really about Wi-Fi setting. Let me show you another file. I already captured the corresponding Wi-Fi frames off screen. In the right side, this is the Wi-Fi frames I captured, starting from this one. See, this one looks a little bit different than other Wi-Fi frames. It shows you, okay, this is from TA and sent to RA, and then the frame followed. It doesn't have the source, and the destination is the first computer, and then the third is from the first computer to the second computer. So let's try to understand what are these frames. By the way, they are all Wi-Fi frames. The first one, if you expand the IEEE 802.11 section, you can see it just has a receiver and a transmitter. The transmitter is the first computer. The receiver is the access point. This particular frame has nothing to do with the second computer. It's just the first computer tried to start the communication, so it sends request to the access point, telling the access point, okay, are you ready? I'm going to send you something. And then the second frame, see, the receiver address is the first computer, and it simply says, okay, clear to send. Basically, the access point tells the first computer, okay, I'm ready, you can send. Then the third frame, this is the one we want to look into the details. If I expand this QoS data section, you can see this very complicated address part. Totally 6 addresses. We are just trying to ping from the computer 1 to computer 2. Why? It involves 6 different addresses. The BSSID, that's the access point, right? And the second one is the STA address, Wi-Fi station address. This is the first computer's MAC address. So these two are easy to understand. Then go to the beginning, starting from the receiver address. See, if you compare the MAC address, it's the same as the BSSID. So basically the receiver is the access point. The transmitter is the first Apple machine. The destination is the second Apple machine. The source address is the first Apple machine. Even though from the Apple machine perspective, from the application perspective, you are just trying to ping from first computer to the second computer, right? But because you are doing that on Wi-Fi, the first computer will send something to the target, to the second computer through the AP. The first computer is not directly connecting to the second computer. It's sending something to the AP, and the AP will know, okay, even though you send this frame to me, but what you really want to do is to send it to the destination. That's how you can understand these 6 different addresses in the single Wi-Fi frame. That's what really happens on the air when you just ping from one computer to another computer. Another thing is, as you can see, all the 6 addresses, they are in the MAC address format because we are talking about layer 2 Wi-Fi. From the first computer, you can get the mapping from MAC address to IP address by checking the ARP table. Let me run the ARP command by checking the interface EN1, which is for Wi-Fi adapter. Yeah, as you can see, the .1.68, which is for the second computer, and it lists the correct MAC address here. We will revisit the ARP table later. In the second scenario, let me connect the 2 Mac machines to the same SSID, which has the client device isolation enabled. You can see in the 2 Mac sessions, they are already connected to the SSID. There shouldn't be any surprise when I ping the computer 2 from computer 1. It shouldn't be pingable. Yeah, as expected, it's not pingable. And let's launch Wireshark to capture the Ethernet packet. I already started frame capturing. Let me ping the machine 2 again. Okay, so this computer 1 issued a ARP broadcast. Ask who is this IP address. The IP address owner should tell the computer 1, but no response because the computer 1 doesn't know which computer has the target IP address, so it cannot complete the ping, right? But let's see what really happened from the Wi-Fi perspective. In the lower right part of the window, I'm showing you the captured Wi-Fi frames. By the way, I already filtered on the MAC address of the computer 1, so you only see these relevant frames. If you compare the left side, the Ethernet ones, you can see, okay, starting from this frame, the first computer sent the AP a request to send. Then the AP replies, okay, you're okay to send. Then the first computer send out a request. But this time, this frame is corresponding to the left side, the ARP broadcast. So if you check the frame details, you can see the 6 addresses we mentioned in the scenario 1. The same BSS ID, the same station, the first computer, the same transmitter, the first computer, the same receiver, which is the AP, but this time the destination is different. It's broadcast or F MAC address. The first computer need to know the MAC address of the second computer. Okay, so the first computer sent out this request but never received response because the first computer didn't know who is computer 2, so the ping failed. Right? That's the effect of the client device isolation setting. Okay, it seems we got the answer and we are okay to move on, right? Hold on a second. You may ask, if the only way for the AP to prevent this computer to communicate with other computer on the same AP is to refuse the ARP request, then what if the first computer make up the ARP entry, manually create a ARP entry, and then can the computer walk around the limitation and successfully communicate with another computer, right? That's a very legitimate question. Let's try to answer it. So in the terminal of the first computer, let me first display the current ARP table. Okay, you can see the ARP entry for this IP address, which is the second computer. The MAC address, it says incomplete. It does have an entry for the second computer because the first computer did send out a ARP request, right? But it couldn't receive response. That's why the entry is incomplete because we already know the MAC address for the second computer, right? So let me manually add an entry to the ARP table. This is what I'm going to do. I will run the ARP command. S means static. I will add a static mapping between this IP address and this MAC address. I'm saying, okay, this mapping is for the EN1 interface, which is the Wi-Fi adapter. By the way, I need to have the root access to do it. That's why I have a sudo here in the beginning. Okay, let me write. Okay, done. Show the ARP table one more time. See, this time is different. So for this particular IP address, now it has the mapping, even though here it says permanent, which means it's not dynamically derived, it's manually added by me. So now we have a supposedly working ARP entry in the table. Now let me try the same ping again. Let's see whether I can work around the limitation on the AP side and successfully reach out to the second computer. In the background, I already started the Wi-Fi frame capturing for Ethernet. Let me ping the second computer again. Okay, it's still hanging there and later it will fail. Okay, failed. So let me stop the capturing. Let's see what happened. See here, the first computer pinged the second computer and it is ICMP. It did send out the packets, but see the color? Because it never received response. That means our try failed, which is good news. That means I cannot simply make up a ARP entry and then work around the limitation, right? Let's check the captured Wi-Fi frame. Let's see what's the difference this time. See, starting from this frame, so the first computer send a request to the AP, and it is a request to send. The AP responded, okay, it's clear to send. And then the first computer did try to reach out to the second computer. See the destination? That's the MAC address for the second computer. Where the first computer got the MAC address? Because we manually added the entry, right? So the first computer thought it had all the information. That's why it did send out the ICMP packet. But it wait forever, never received the response. So the Wi-Fi frames correspond to the Ethernet frames we captured. So the first computer did send out the packet, but never received the response. So we are completely successful in this scenario. The limitation on the AP setting works, and we didn't work around it. Now let's move on to the third scenario. Okay, in the third scenario, the first computer will use the SSID, which has the client device isolation enabled, but the computer 2 will not have the setting enabled. Let's see whether these two computers are able to communicate with each other. From computer 1, let me ping computer 2. As expected, it cannot. But the tooltip from UniFi network controller for the SSID setting doesn't really tell us whether the computer 2 will able to reach out to computer 1, right? Let me do it from computer 2, ping computer 1. It cannot. Okay, we are good. Let's move on. Okay, in the fourth scenario, it's similar to scenario 3, but this time I'm going to use 2 access points. The reason I want to test this is the setting tooltip in UniFi network controller keeps talking about one AP. It doesn't explain if you have multiple APs, whether the isolated client is able to communicate with devices on other APs. So let's test it out. In the right side UniFi network controller topology, you can see now the two computers, they are connected with the same AP. To connect the second computer to the other AP, let me set the Wi-Fi client. Go to settings. Let me force the access point to U6 Pro. Okay, in the refreshed topology, you can see they are connected to the desired AP. And from the labels, you can also see one connected to the yes SSID, the other one connect to the no SSID. We are good for the testing. From the first computer, let me ping the second computer. Okay, it's not successful. So which means this client device isolation setting, it works not only within the same AP, but also work on the clients which are connected to other AP. Then let me try from the second computer. Let me ping the first computer from second one. Okay, this time it's interesting. Remember when the second computer resides on the same AP with the first computer, the second computer couldn't ping the first one, right? But this time the second computer is able to do that. Maybe that's something you need to keep in your mind. Okay, in the last scenario for this video, let me use a Linux virtual machine which is connected to the wired part, not Wi-Fi, not connected to either AP. So let's see whether the client device isolation setting still works with a wired client. From the network topology, you can see the same thing. Debian machine is connected directly to the switch. So from computer 1, let me ping the Linux machine. See, it's another interesting result. Let's double check. The Wi-Fi setting is client device isolation enabled, right? But the computer is able to connect to the wired Linux machine. Then from the Linux machine, let me ping the first computer. Okay, it's pingable. So the scenario 4 and the scenario 5 both lead to some interesting and kind of unexpected results. So basically the way it works for UniFi's client device isolation setting, it only completely works for the devices on the same AP. The AP is aware of the client device isolation setting. It will prevent your Wi-Fi client from communicating with other devices. But if the other device is not connected to the same AP, it cannot do anything about it, and your communication will still be successful. Don't treat the client device isolation as something like guest Wi-Fi SSID. No, it doesn't work the same way. Thanks for watching. This is the end of the video.